Okay, so here we are talking about binary classification where y is either 0 or 1, and we are talking about why linear regression is no longer a great choice. So let me show you with a diagram. So suppose we have one feature x1 and we have y. Some of them are 0 and others are 1. And the suggestion was to run a linear regression through these points and then say have a cutoff, say 0.5. So the linear regression is y is w transpose x, and our classification is either 0 or 1. This happens if y is larger than 0.5 and 0 happens otherwise. So basically you draw a vertical line here at 0.5, on the right is 1, on the left is 0. However, this is obviously wrong. Let me show you by adding another few training data points, say there. So adding points here should not affect the result, because if you classify it the same way, it will still work. However, if you run a regression, you would have a line like this. So when you use the same rule, let's extend this, and on the right is 1, on the left is 0. Suddenly there are points who are classified incorrectly. So what's the problem here? So the main problem is when you do least squares linear regression, the least square comes from the cost function, which is the sum of these yi minus wi transpose xi. So in this diagram, what is the cost for these new points? Let's extend this line and say this is this cost. I forgot the script. So these points, according to the original line, so according to this line, it's classified correctly, but the cost is very large. So in order to minimize the cost, it would change the line so that it gets closer to something that's already classified correctly. So that's the main problem with least square. So that's the main reason with binary classification, you cannot just run a linear regression and then somehow convert it to either 0 or 1.